We know that sedimentary rocks form when sediments get buried and experience enough pressure to compress them together. But what happens when those rocks keep getting buried and buried and buried until the pressure is extreme? Well, we also know that igneous rocks form when superhot mineral mush crystallizes. But what happens to all of those rocks around the magma chamber? I mean, they feel the same extreme heat too, right? Well, these extreme conditions make extreme rocks called metamorphic rocks. And not surprisingly, they are igneous or sedimentary rocks that have to change to survive these new conditions. Rocks that metamorphose due to pressure and rocks that metamorphose due to heat are both called metamorphic rocks, but they really couldn't look more different. First, let's talk about metamorphic rocks that form due to pressure. These rocks may seem nice, but they've been around the block and they've seen some schist. Let's get on with this video so I can show you what I mean. Now, great pressures on Earth are found in special places called convergent and transform tectonic boundaries. These are places where the Earth's crust smashes or grinds together. This cartoon shows a convergent boundary where two bits of crust are smashing together and one is deforming into a mountain and one is being pushed underneath. Well, take a look at that collision zone. See all those wacky wavy lines? They used to all be horizontal and flat, but, well, the pressure got to them. It was so great that it folded them up like paper. All that compression takes the mineral grains in a rock that are pointing in whatever orientation they found space in and smoosh them together into nice little flat lines that take up much less space. These nice little neat lines are called foliation, and they're the signature of metamorphism due to pressure. So pressure equals foliation equals stripes. The more pressure, the smooshier and bendier the lines. Another thing to keep in mind is that the pressure also often generates heat because of friction. So the stronger the pressure, the more the rocks are partially remelted, which leads to the behavior of non-foliated metamorphic rocks. These rocks form due to extreme heat, and because of that, they don't have those foliation patterns. So, cleverly enough, we call them non-foliated. These rocks form under low pressure and extreme heat, usually right under a magma chamber. The rocks surrounding a magma chamber literally cook their minerals. So what does a cooked mineral even look like? So they're partially remelted, and what this does is return some of the minerals into a mushy state that allows those crystals in the rock to regrow a little bit. Okay, so remember those intrusive igneous rocks we talked about before? Now they form in a magma chamber that holds its heat for a long time, which allows them to grow large crystals. Well, that means that these metamorphic rocks, which are right next to that magma chamber, also get a long time to let their minerals crystallize. So that means that their minerals get big too. But remember I said partially remelted. These minerals in these rocks never melted all the way into magma. That would make them igneous rocks, and they're not. They're metamorphic. What this means is that these big crystals are not growing naturally into their crystal habits. They have limited space to grow in, and they take up all of that space. So instead of the quartz and quartzite showing that nice tetrahedral shape, they're all blobby. And same with the calcite and marble. No nice blocky shapes, just all blobs. Okay, so now that we know how these rocks form and what they look like, let's talk about their names. Okay, this is a graphic from your textbook. It shows all the metamorphic rocks according to their texture, so foliated or not, right? And how foliated, and their mineral chemistry. We start with slate, which is very fine-grained and you can't really see the stripes, and phyllite, which is also very fine-grained, and the stripes are really bendy. And what's interesting about phyllite is now we are adding a little bit more of heat, and so we're getting some remelting, which means that those minerals now get to have a kind of a more glossy sheen to them. Right? More pressure, more heat gets us schist. More pressure, more heat gets us gneiss. In the non-foliated, we have marble and quartzite, depending on whether we had a calcium carbonate limestone or we had a quartz sandstone to start off with it. So there you have it. The extreme, the beautiful, the nice. Yes, again, it's nice. That is how it is pronounced. These are all wonderful metamorphic rocks.